Right? So this is the basic graph of y equals 6 over x, the one that I just put on the other side, y equals 6 over x. And you can see what the graph looks like. Right? It has two parts to the graph. Right? This is what you call discontinuous graph, because I could draw one part of the graph, but in order to draw the other part of the graph, I've got to pick up my pen and go to the other part and then draw that. Each one of those is called a branch. And you would say that because these two branches are split right at x equals 0, we would say x equals 0 is the point of discontinuity. It's where the graph breaks. Now, you can see they did a table of values. I'm not interested in doing tables of values, right? If you want to do a table of values, put it in the calculator, go to the table of values, knock yourself out. We need to understand the graphs and understand the shapes. Like I said, rational functions are characterized by asymptotes. What you can see on this graph, and I'm going to do it here, make it a blue because they used red for the graph. But it does have an asymptote on the y-axis. It has an asymptote on the x-axis. And it has the asymptote on the y-axis because you cannot substitute x equals 0. You'd be dividing by 0. Right? And it has an asymptote on the y-axis because there's no value of x that we could substitute to make y equal 0. And y equals 0 on the x-axis. There's no way we're ever going to touch that x-axis. And we're not allowed to do x equals 0, so there's an asymptote there. Right, so the equations for these, which we already know because we've done these before, this is x equals 0, this is y equals